This is the model of the 3D retaining wall. This is the backfill soil and this is the foundation, and here is the retaining wall. I have already defined the material properties for the foundation soil, backfill soil and the wall, and also assigned 3D solid property to each of them. Next, we will proceed to meshing the geometry. So we go to mesh and 3D and auto solid. First of all, let's begin with the stem 0.5, and we will be selecting hybrid measure. The property I'll be selecting is wall, and let us name it as stem. Next is the base. So base, apply. Then the backfill soil. For this backfill, and the mesh set is backfill, and then apply. And finally the foundation soil. So soil, and I'll name it as soil, and then OK. So now the meshing is complete. We can also check for free faces. So there should not be any free faces after the completion of meshing. Next, we are going to create interface element between the stem and the backfill soil. So for that, we have to go to interface, and for 3D model, we have to provide a plane interface. In the type, we can select from mesh set, and we'll select the two meshes. The property parameters right now I am taking it from wizard, and I don't want any rigid link for this stem interface. Let us name it as stem interface, and then apply. So the interface element for the stem that has been created, this one. Next, we have to create interface between the base of the wall and the foundation soil. So selecting the two meshes. Again, I'll use wizard for interface property parameters, and I'll be creating rigid link for this one. Let us name it as base interface. So this is the stem interface, and this one is the base interface. Also, after creating the interface elements, plane interface elements, we need to check whether the local coordinate axis of all these interface, they are in the same direction or not. So let us begin with the stem interface. For the stem of the retaining wall, we are interested in the normal force acting on the stem that will give the active earth pressure. So for that, we should check that the normal coordinates for each of these elements, they should be aligned in the same direction. So right now, for all the elements, the normal axis, that is the x-axis, it is in the same direction. So this one is fine this time. But if we look at the base interface, so for the base, that is interface between the base of the wall and the foundation, we are interested in the normal force as well as the frictional force. So for that, we have to check whether the normal axis, right now it is the x-axis, and it is in the same direction for all the elements. So that is fine. But if we check the horizontal axis, that is that one which will be showing us the frictional force. So we can see that these are having different directions, means this is the negative y-axis, and this time here it is z-axis. This is the positive y-axis. So we need to align all these elements so that they have the same direction or same orientation of their local coordinate axis. So for that, we will go to parameters and then other, change CSYS. Now we have to select the objects. So Let's start with this one. Either we can select any base element, and after selecting the base element, the all the other elements coordinate system, they will get aligned according to the base element. Or we can just shift orientation such as this one. So right now let us consider that we have to make all the elements point so that they have y-axis in this direction, such as this element. So this is done. Now let's proceed for this element. So select this element, and yes, this is also complete. So in this way, either we can use shift orientation or we can use base element and then accordingly align the elements to have the same local coordinate axis. So these elements are fine. Now this one. These elements. So using either reverse normal or base element or shift orientation, we have to make sure that the local coordinate axis for each of these elements of the interface, that is the same for all the elements. So now this is the same. Next, we will proceed to define boundary condition for general stress analysis, and then self weight. Then we are going for a construction stage analysis. So we will go to add construction stage and let us name it as retaining wall. So the first stage will be the in situ stage. So there will only be the soil, boundary set, and load, gravity loading condition. And we are not interested in the displacement due to self weight. So we'll check on clear displacement. Let's name it as initial. Save. Then the next stage is retaining wall. So here base, then stem, also the rigid link mesh connecting them, and then clear displacement. Save. Next, backfill. So stem interface, base interface, and the backfill soil. Save. So these are the three stages: first stage, second, and the third one. After defining the construction stages, we'll add the analysis case here: construction stage, retaining wall. In analysis control, we have to enable initial stage for stress analysis and apply K0 condition. Next, we proceed to run the analysis. So I have already completed one analysis and we can proceed with the results for this analysis. So this is the post mode tab and in the results, uh, first of all, let us start with the STEM interface. So here if we go to display and enable nodes, so all the nodes are visible. Then in results under backfill, we will go to interface stress and normal X. So after this, we have to go to extract and the result type is interface stress, normal X, node or element. Let us select a particular section, node set one particular section. Let's say at this section, we will sort it in the Z direction and we go to table. So after this, what we will do is we will export it to Excel. Normal X stem. So now this is the force on the interface in the normal direction on the stem. What we can do is we will find out the resultant of this force. So that will give the normal force on the wall due to this backfill. Due to this backfill, the normal force on the wall, we can find out the resultant of this force. Similarly, for the base interface, this is the base interface. So the normal force on the wall and the frictional force on the base. Dividing means if the friction, when we need to calculate the factor of safety for sliding, then we need to know the when we are interested in calculating factor of safety for sliding, then we need to know the frictional force which is acting on the base of the wall and the total normal force which is acting on the stem of the wall. So, if this frictional force is greater than this normal force, then there won't be any sliding. Or if this normal force is greater than this frictional force, then the wall will have tendency to slide. So the factor of safety will be like given by resisting force upon driving force. So resisting force will be the frictional force and the driving force will be the normal force on the wall. So how do we calculate the normal force on the wall? We just need to find out the normal force on the wall is nothing but the normal x direction force on the stem interface. We will take one particular section and then we will export the results to Excel. After this, we have to calculate the resultant of these forces. Now next is the frictional force on the base. So for that, we go to base interface and in the results, so if I enable the element coordinate axis here, so we can see that the direction of frictional force should be the y direction, this green one. So we will go to tangential y. Next again we will go to extract and interface stress, tangential y, node or element. Let us select one particular section, let's say this section, and we will sort it in the x direction and we go to table. Now again we will export it to Excel. So this is the frictional force which is acting on the base. We will find out the resultant of this frictional force. Then factor of safety against sliding, that will be given by resultant of this frictional force divided by the resultant of the normal force which is acting on the stem. So this is how we can obtain the factor of safety for sliding. Next, to calculate the factor of safety for overturning, so For overturning, we will have resisting moments and driving moments. So let us say, next we have to calculate the factor of safety for overturning. So let's say we are calculating it, we will have resisting moments and driving moments. So let's say we are calculating all the moments with respect to this point. So we can calculate factor of safety against overturning by, we will know the resultant normal force acting on the wall by the normal X force on the stem interface, which we have seen just now, this one. Then we will know the location of that force. We will multiply the distance of the resultant force from this point to get the overturning moment. So this is how we calculate the overturning moment. Next will be the restoring moment. So the restoring moment will be the normal force acting on this base. We will find out the resultant of this normal force and its distance from this point. Multiplying these two, the normal force and its distance, will give us the restoring moment. So factor of safety against overturning, that will be the ratio of the restoring moment with the overturning moment. So for the restoring moment, we need to find out the normal force which is acting on the base interface. So for that, let us just enable base interface, and in results we will check the normal force which is acting on the base interface. Again, we will go to extract and interface stress normal X. Let us select it at one particular section, let's say this section, and sorting it in the X direction, and then we go to table, and then again we will just export the results to Excel. So normal X base. So now we have to find out the resultant of the normal force which is acting on the base, resultant of these forces, and then the location of the resultant will also be calculated, and it has to be multiplied by the distance between the resultant force and this point. So that will give the restoring moment. Similarly, for the overturning moment, that will be the resultant of the normal X force acting on the stem interface, which is this one, multiplied by its location, means its distance from this point. Then we can calculate the factor of safety by, that is the ratio of restoring moment by overturning moment.